All right, so we're going to talk a little bit about today. First of all, I just want to let you know, I'm not an NPE, but I have one very close to me, and I discovered it many, many years ago, back in 2011, 2012, which in the DNA world is a long, long time ago. So, and we're going to talk a little bit about that today. Also, I'm going to throw in a little bit about how to find NPEs in your family history, not just in how to work with DNA as far as identifying a birth family for yourself, but one of the things I've actually just run across recently, there's been two recent NPEs we've discovered in my husband's family. One is a first cousin once removed, meaning that one of his first cousins was the birth father. We've identified that birth father. I'm now working with an adoptee out of the Portland area who we've discovered we have 2 generations of NPEs in his birth father family. So it's important to understand that you may find this, and actually the funny part is we're all finding this in our families somewhere, okay? All right, so let's get started. And hopefully, since I usually read from my slides, we'll see how this goes. So how can DNA testing help you with your genealogy? And with identifying NPEs, right? So it's going to tell you if you and another person are related or descended from the same individual. How many of you gentlemen have done Y DNA testing? Just a few of you. Well, okay. So that's one way that oftentimes people men in particular, first find out that they don't have the surname they thought they did. Okay, and that's what happened with my family member. It can tell you if your documented family history is on the right track. So you'll know if what you've traced so far, and see that's where sometimes people find they've got an NPE, say at grandma. All of a sudden they have no DNA matches on one whole branch of their tree, and now they're wondering why not, okay? If you can actually map parts of your genome, and we won't talk about that today, but if you've heard of things like visual phasing or chromosome mapping, for those of you who've worked heavily with DNA, that's something that you can do as well, and determine which parts of your DNA came from which of your ancestors. And then ethnicities, of course. You've all seen those lovely pie charts that the different companies give you, and have other people that maybe get a little bent out of shape about them. It's kind of amusing. I'll talk more about those in a minute. And then, of course, it can tell you if your documented family history is wrong, and it can and in that case, in some cases, that's how we find out we're an NPE. Right? We think we know what our family tree is, and yet we get there and half our family tree have no matches. Okay, or certain people start showing up in our match list at the very top that we've never heard of before. Okay, all right. So let's go back to junior high basics of DNA. 10-minute lesson. This is in your handout, so hopefully you can follow along. So DNA is deoxyribonucleic acid. Say that 5 times fast. Double helix consisting of 23 chromosomes, 23 pairs, okay? 22 of those are what are called autosomes. So autosomal DNA testing is the kind of test you take at Ancestry, or 23andMe, or Family Tree DNA's Relative Finder, or Family Finder, excuse me, MyHeritage. Those are autosomal tests. That 23rd pair is the sex chromosomes, okay? So that's you. If you're a male, you have an X and a Y. Genetically, if you're a female, genetically you have 2 X's, okay? Those autosomes are interesting because a child gets 50% of those from mom and 50% from dad. And the DNA recombines every generation. So that makes it kind of challenging, whereas the Y DNA gets passed almost unchanged from generation to generation, father to son to grandson to great-grandson, and so on. Autosomal does not. And I'm sad that you aren't going to see these pictures because they're really fun, but hopefully we'll get there in a minute. This is, which you can hardly see, but this is what chromosomes actually look like under a microscope, electron microscope, and they're up in this corner, you can't see it, but this is chromosome 1 and it's really big, and down here's chromosome 22 and it's really tiny, and I really think they just lined them up big to little and said we'll just name them 1 to 22. And then you got 23rd over here, which is the XY. We're not going to talk about that one today. Okay? All right. So let's talk. I don't know if you can see this. I hope you can see it. Unfortunately, the white part's kind of missing. We're going to talk about the basics of recombination because it's really important to understand how DNA is inherited. Okay? Because autosomes control things like hair color, eye color, height, weight, build, skin tone, all of those things, okay? And so it's important to understand how these things are passed down. So when gametes are made, so a sperm and an egg, when they're created, think about this. If you have a sperm that has 23 pairs and an egg that has 23 pairs, how many do you end up with if you put them together? 46, right? That's not good. We know even getting one extra chromosome is bad, right? So what can happen, what has to happen, oops.
I'm just messing with it. Keep going.
Okay, so what has to happen is that those chromosomes have to split. And you get one set, 1 through 22 in a sperm, and one set, 1 through 23, excuse me, 1 through 23 in an egg. So that when they come together, they have full pairs, all right? Now, in the process of that, they do what's called crossing over or recombining, okay? And if you can't see it, but there's a white chromosome here. So if this is the chromosome 1, we're just looking at one chromosome out of 22. If this is chromosome 1 and this is from mom, the black one, and the white one is from dad, what they do is they break up into, you can see they look like little beads. At least I hope you can see that. And the same thing with the white one, and they actually cross over and they switch. And now you have a chromosome that has this half from mom and this big half from dad. And the opposite one has this small part from dad and the big part from mom. And each of those goes into a separate sperm or egg. Now, that all sounds very technological and biological and all of that. But think about the realities of that. Can you see how two children of the same set of parents could potentially inherit different traits based on just one chromosome event like that? Okay? What if red hair is on that part right there, and this child didn't get it? They aren't going to have red hair, are they? Especially since it's recessive and you got to have a lot of other things go happy for that to work. Okay? So it's important to understand crossing over and recombination. It sometimes happens twice. You can't see this, but you've got a crossover here that actually happens twice. Sometimes it happens 3 times. Sometimes it doesn't happen at all. We actually have cases in the genetic genealogy community of folks who've been able to test 3 generations, and they found where the grandchildren have gotten a copy of a chromosome wholesale from a grandparent. So while you get 50% of your DNA from mom and 50% from dad, after that, all bets are off. It may not be exactly 25% from grandma and grandpa all across the board. You may get 26 from one, and 24 from another, and 23 from another, and 27 from another, just based on recombination. And if you throw cousin marriages or endogamy into that, which if you have Jewish ancestry, plan on it, that just messes things up even more. Okay? Or Southern ancestry. Yeah, anybody that lived on an island, Puerto Rico, come on, it's true. And I have frontier populations that moved out to the frontiers very, very early, and they are heavily endogamous. I tease that my grandma was her own cousin. So here's some evidences. You can't see this, it just makes me sad. This is my husband and I on our wedding day like 31 years ago. And here's our children, and you can't see them. This makes me so sad. Oh, maybe that's it. Let's see if we can.
Do you guys remember where we found the brightness?
Color temperature? No, it's
right
probably.
and left. Go to the right and left.
Go left because you're at picture right now.
There you go.
OSD.
Do you remember where we found the brightness?
We're going to try to fix this real quick. Oh, there it is. Brightness 100. Oh, zoom down. Keep going. Keep going. And there, Mary and Dave appear as if by magic.
Is that better or worse?
It's better, yeah. Still can't see Melissa, she's in the light blue dress, but that's okay. So here's my middle daughter, Rebecca, and here's my son, Michael, whose face is now hidden by the menu, but that's okay.
She has a black screen back.
It's a blue, it's dark blue, yeah.
So it's much better.
Okay.
All right, so that's better than it was. Good, maybe this won't be completely hopeless, okay, a little bit. So there's my 3 kids. Here they are as like seniors in high school. So this guy is Mini Dave, right? Couldn't deny that kid if his life depended on it. This is Mini Me, and this is what my son fondly refers to her as the hybrid. If the middle child didn't have enough issues already, right? Okay, so So it's interesting because we start looking, don't we? We look for those traits, and that's how some of us figured out maybe early on or had an inkling that something wasn't quite right. We didn't see ourselves in one of our parents. This is the second generation, so my oldest daughter's married. These are my 3 grandbabies. This is the favorite part. This is just an excuse to show off my grandkids. But the fun part is that this is her mini-me, this is his mini-me, and we think now this might be the hybrid. So at least he's not the middle kid. But it's interesting how we look for those traits. We recognize that even if we don't understand anything about DNA or inheritance or anything else, we know that we should see our nose in somebody, right? One of those kids. All right. So what does autosomal DNA test? Well, it tests ethnicities, and I'm going to talk about that and dispense with it very quickly here at the beginning, and then we're going to move on to other things. And somebody please give me a 5 minutes or 10 minutes when, thank you, because I could go on. This talk normally takes 2 hours, so we're doing it quickly. So I apologize if I speak fast. The 22 pairs of chromosomes other than the sex chromosome. Now, at 23andMe, you will get a sex chromosome, or you'll get a Y or a mitochondrial haplogroup. That's a huge group that tells you where you fit on the big DNA family tree. It does not have anything to do with autosomes or matching, so it's a totally separate topic. But it can show relationships between siblings, parents and children, aunts and uncles, and cousins back about 5 to 6 generations. Now, anecdotally, people have gone back farther than that. If you get a big chunk of DNA that kind of gets sticky and wants to get handed down, you might find evidence of that. But when you get really small matches, segment matches, like below 7 centimorgans, and I'll talk about what centimorgans are here in a minute, things start getting a little dodgy. I don't trust them. I generally won't work with them. So you've got to remember how these are inherited. So we talked a little bit about recombination. So this is practical recombination, okay? You've got grandma and grandpa up here on dad's side. And this is pink, by the way. You can't really tell that. They all look white to me. They are different colors. This is dad's father, dad's mother, mom's father, mom's mother. So they get together and they have children, okay? So here's what recombination looks like on just one chromosome on dad's side. So it's blue here, pink in the middle, blue here, okay? So that came from here. This one recombined to create this copy of chromosome 1 for this man. And the same thing's happening over here, but we're just gonna focus on this side. Now, this couple get together and they have 3 children, okay? So you've got 3 kids, and you can see that the recombination, they got some of the same DNA, didn't they? But they didn't get all the same DNA, unless they're identical twins. If you have fraternal twins, you get a boy and a girl, or even 2 boys and 2 girls that are fraternal, they're just like regular siblings, DNA-wise. There's nothing, they're just like if they came out of the womb at 2 years apart, okay? But what's interesting about this, if you think, I always joke when I teach this to genealogists, this is the genealogist, child number 3 over here, and the brick wall in the family is grandma's mother's line up here, which is white. And what you can't tell from this, but what you would know if you could see the real colors, is that this child has no white. Now that's not realistic. We always get DNA from our grandparents, but we might have gotten none on chromosome 1. This is one of 22, remember. So, if mom and dad are deceased, you have to test as many siblings as you can. And so for those of you who are Npes who are working with a potentially deceased birth parent, you're going to want to test the children of that person to try to determine relatedness, okay? That's the ideal. You may end up having to test a sibling of theirs if there are siblings still living. That could work too if the children will not test. All right, any questions about this really quickly? I don't want to get too deep in the weeds on this, but I just wanted to cover it just in general. Does it make sense to everybody? Okay, good. All right, so let's talk quickly about ethnicity, because we have to just get this off the table. People get really hyped up about this, and this is probably even more true in the genealogical community. They're like, I have 5% of something, and I have no idea where that came from. Or what's worse is I have less than 1% of Iberian Peninsula, and they're out looking for their Portuguese ancestor, which just kills me. I'm like, just let it go, okay? And the interesting thing about these is that you have to remember, these are estimates. That's why they're called ethnicity estimates, and they're only good to the continent level. I want to let that sink in for a second. Continent level, meaning Africa, Asia, Europe. So when they tell you you're this French versus that German, yeah, if you lived in Alsace-Lorraine, it depended on what day of the week it was, right? Because the border kept changing, and today you're French, and tomorrow you're German. All right? DNA didn't care where the boundaries were of all the countries we now have. And it moved with all the people that moved with it, okay? So when they try to make these estimates, you have to realize they're doing that based on a reference population. They're testing living people today and saying, okay, you, because you have, all your ancestors for the last 4 generations have lived in this village in England, you are going to represent English DNA. Well, that's lovely, except for I know somebody who's part of the founder population for MyHeritage, and when she got her test back, she said to me, guess what? And I knew what was coming. She goes, I'm not 100% English. And I'm like, well, of course you're not. She has Scandinavian. She probably has a little Western European. You think about the British Isles, how many different peoples went smashing through the British Isles at different times? Now that's an island. It takes work to get there. Let's talk about Western Europe. It's a joke, right? And Eastern Europe as well. So while some populations are very easy to segment and to separate out, Jewish, very distinctive because they married within their population. So that DNA has become concentrated, if you will. And some other populations, Finnish, and some others are very easy to distinguish as well. But when it comes to Western Europe, Eastern Europe, if it's going to tell you Ukraine versus Poland, yeah, good luck with that because they were each other at some point. Okay? All right. And so you will get different results from different companies because they have different reference populations. It's not the same people that are testing at each company to do that. Do you have a question? Or?
I heard that the Vikings were actually proven to take over Ireland.
Oh, the Vikings took over everything.
Yeah.
If you look in 900 at the Danelaw, it covered most of England and Ireland and Scotland. It covered part of Western Europe, most of Scandinavia, and part of Spain. Yeah, no. The Normans, the Norsemen, guess what? They were Vikings. Yeah, so, all right, they weren't French. We like to say they were. All right, so you can distinguish things like African ancestry, Jewish ancestry, both Ashkenazi and Sephardic. So the Sephardic Jews are the Jews that came from around the Mediterranean, kicked out of Spain and Portugal in 1492. Ashkenazi or Eastern European Jews. And then Native American. Now, what's really important about Native American to understand is you can prove it, but you can't disprove it. If you have a definitive paper trail back to a Native American who came over on the Cherokee Trail of Tears, and you've got them in the Cherokee rolls and all of that, and you've proven the DNA back from them down to you, but you have 0 DNA, Native American DNA, you're still Native American. Okay? Now, if that was grandma and you have no Native American DNA, something's not right. But if you're talking somebody back 4 or 5 generations, the thing you have to remember about a lot of these tribes is they were admixing very early. The Eastern Seaboard tribes in the 1600s with whites from Europe, with black slaves, blacks from Africa. So you've got lots and lots of intermixing going on very early. So that DNA is not very specific at this point. But it can be detected, especially if it was grandma, because you should get roughly about 25% of her DNA. Okay? All right. But you need to pay attention when you find something you aren't expecting. So I imagine Kara, when she got her results and found out she was half Ashkenazi Jewish and she didn't know that, was a little shocked. I've had other friends that have done that. I used to say in my DNA lectures all the time, if you don't want to know the answer, don't ask the question. Because we all think we're who we are, right? We all know who we are, and we take that test, we spit in the tube, we swab that cheek, and we think, oh, this is going to be great, and we get it back and go, what? What just happened? Gal in my local community that her kids and my kids played at school and knew each other for years came to my lecture, and about 2 months later, IM'd me on Facebook and said, remember when you said ... Yeah, she found out she was one of those half-siblings of how many dozens of children from a Jewish reproductive doctor. Yeah, so it happened. She thought she was half Italian. She'd been to Italy to do research. Yeah. All right, so here's, when you see Ancestry in particular, I'm just going to show Ancestry today. That's where most people test. I realize some of you are at other places, but you can find the same information there. You would come over here and click on this part of the website to get your ethnicity. And I apologize, you can't really see this. This is my old ethnicity results. Ethnicity results change, okay? Because it's based on math and statistics and algorithms. And so they get updated. Mine significantly changed. I had a big chunk, like 16% of Scandinavian. I have no Scandinavian ancestry. I have a whole lot of UK ancestry though, so guess what? But this time when they updated it, that all went away. I think I have 1% Finnish or something, which I still think is hokey, but most of it now is UK and Western Europe, which is where it should be. Other people, theirs got less specific or less correct. Okay, so you want to kind of watch that and understand that piece. The other thing you can do to understand this better, if you have questions, is to click on one of these things. So I click on Ireland and Scotland. It opens up this window, and if you scroll down, you'll see there's a little thing here that says read more. Okay, so if you click on that, it tells you more about where this DNA is found. You notice it's a target, right? It's like a bullseye. There's a little bit over Ireland and a little bit of Scotland, but then it gets really big, and it even includes parts of France. So when you click on that and you look here, it says primarily located in Ireland, Wales, and Scotland. Well, what you couldn't see was that the category right above that was England, Wales, and something else. And you're like, hang on, wasn't Wales in a different category? Again, because nobody from Wales went over to Ireland and had children, right? Okay, do you see the absurdity of trying to get these narrowed down? That I don't know that we ever will, realistically, with all the admixing that happened back before 1066, when the Normans invaded England. Okay, it's just not realistic. But you'll also see it says also found in France and England, because nobody from England ever went to Ireland and had children. Of course they did. Okay. All right, and then you can click on up on this little thing up here, which is a question mark, and you can get more help. And it says, how do I understand my reference populations? And it'll tell you here, this is an estimate of what you have, and you can't see it, but basically it's a list of countries, and it tells you exactly how many people are in that reference population. Some of them have 22. 22 people to represent that ethnicity for their whole country. Yeah, so can you see where there's potential problems? So I call this the fun to talk about around the water cooler part. Guess what, I'm 59% British, or whatever. Unless, again, you find something you weren't expecting, then it becomes important. If you take your DNA test and you find out you're 10% Asian, that's real. If you find out you're 25% Ashkenazi Jewish, that's real. Okay, or African that you didn't expect, that's real. You need to pay attention to that piece. Continent, big population kind of things. So definitions, what's a centimorgan? And you can't see it here, but I'll explain. A centimorgan is what the companies use to denote amount of DNA. It's a measurement, okay? The thing you have to understand about this, when the DNA testing companies test your DNA, they're not testing all of it. They don't test your entire genome. They're only testing, I think it's 700,000 SNPs or locations on your DNA that have relevance when it comes to family relationships that they've found, okay? So, based on that, you are given an estimate of how much DNA you share with someone. And that's often where people get the first clue that something's not right. Because either the category that the person has been put under in your match list is not the one you expected, or the amount of DNA you share doesn't line up. I was giving a lecture at my local LDS Family History Center a couple of months ago, and a friend of mine that I've known since high school is sitting there looking at his mother's results, or his results, or maybe it was his mom's, while we're talking about the class, and I'm sharing how much DNA people share. And he says, wait a minute, what? And I said, yeah, turns out his mother was an NPE. And he found out in front of 20 other people in a classroom. It was interesting, is what it was. But that's what they use. They use centimorgans. So how much DNA do people share with a parent and a child? It should be 50%. It's always 50%. Now the rest of this from here on out is averages. And this is on the ISOG wiki, and you have this link in your handout. So it's under the website part. So they share roughly 25% with a grandparent, 50% with a sibling. Half siblings share 25%, which again, if you've let's say your parents are deceased, but you tested yourself and a sibling, and you only shared 25% of your DNA, that may be how you discovered you were an NPE, or they were. Okay. An aunt and uncle, 25%, niece and nephew, same thing. Great-grandparent, 12.5. Can you see where this is going? Every generation it cuts in half because of recombination, right? That's the miracle of recombination. All right, second great-grandparents, 6.25%. First cousins should share about 12.5%. As they become removed, that splits in half. Does everyone understand removes? Does anyone not understand removes? Raise your hand. Okay, so and how many of you just won't admit it because you have no idea what I'm talking about? Okay, so, and normally it wouldn't matter, but the problem I have noticed when I teach this is that people who think they understand what a remove is don't really, and it affects how you look at your DNA and where you look for people who are your birth parent, birth grandparent, cousins, how those cousin relationships are affected. Second cousins, 3 1/8. Is that right? Yeah, 3 1/8. And then that halves each generation they are removed. Third cousins, okay, at third cousins you're sharing less than 1% of your DNA. That's not very much. And so while all second cousins share DNA, only 90 to 95% of third cousins do. Okay, at fourth cousins it drops to like 50 to 70%. So if you have somebody on paper that you know is a third cousin and they're not matching you on their DNA, it's okay. Take a deep breath. But what's interesting to note is you all got DNA from that common ancestor. You just may not have gotten the same piece. And that's what makes you a match. You have to have the same piece. Okay? All right, you look out here, fourth, fifth, and sixth cousins. Holy cow, by sixth cousins we're less than 1/100%, or just over 1/100%. So that's not much DNA. So that's why this works about 5 generations back. All right, so here we're going to figure out removes. Okay, so you've got this common ancestors. They have 2 daughters who are what to each other? They're siblings, they're sisters. Okay, and what are their children to each other? What about their children? Second cousins, their kids? This is getting redundant, isn't it? Whether there's 4 or 4. All right, so what happens though if you want to know how Julianne Parker is related to Eleanor Carter? Okay, they are. You always go back to the flat cousin relationship or the full cousin relationship. So in this case, that's what? First cousins, right? These guys are first cousins. And then you count the number of generations from that relationship. So 1 down, so that is a first cousin once removed. Okay? What about Julianne to Mary Louise? Down here. First cousin twice removed. Good job. What about Harriet Ford to Sarah Ann Matney? Okay, so I heard it. Second cousins twice removed. Good job. You guys all pass. You get to eat lunch. Did you have a question?
No, I'm just saying yes.
Oh, yay. Yeah, we pass. We get to eat. All right, so that's important to know that because what happens is at some point when you share a certain amount of DNA, there's a range of relationships you share. Okay, I have 10 minutes. Are you? Oh, I thought. Oh my goodness. Okay, go ahead.
Does it go up the other way? Can you be a first cousin once or second cousin once removed going
Up? Well, it depends on where you're sitting on it. So from Sarah, yes, Harriet is her second cousin twice removed, whether she's down here or Harriet's up here. It doesn't matter.
Okay.
Yes.
So if for some reason Harriet and Eleanor were half siblings,
Then they're half. So they're half second cousins twice removed, and the DNA cuts in half at that point. Yes, so it does matter. Half siblings do affect this. Yes.
How do you write that?
I write half, 2C, 1 R, 2 R. Yeah, no, I write it in. You do write that, yes.
I've heard about ghost trees, creating a ghost tree
Uh-huh,
to figure out how you're related to someone.
Right.
or my best friend from high school, we figured out we're fifth cousins.
Okay.
We're not linked on Ancestry.
Mm-hmm.
How do I figure out who our common ancestor is?
You do a lot of genealogy research.
Okay.
If you linked your tree should tell you who your common ancestor is. You just have to find which line it's on and go back that far.
We know who our,
You share fourth great grandparents if you're fifth cousins. So it would be one of your sets of fourth great grandparents. Okay? All right. All right, so let's talk about Ancestry Matches. Again, I have way more material than we're going to be able to cover, but I'm just going to try to get through at least one case study, and I might get through two. But it's going to be hard to see these, so we'll just do the best we can. So for your matches, you're going to be clicking on this middle part right here, okay? And you're going to get a match list, and this is sad. This is my sister, my full sister, okay? These are my aunts and uncles on my dad's side and one on my mom's side. And so most of you have seen, now does this, what you can see of it, screen look familiar to most of you who've tested at Ancestry? They just changed on July 1. Everybody's in the beta now. It's no longer a beta. You have this match list. It used to look different. Giving these lectures is really fun because they change their screens like every 2 weeks. So I get to do new screenshots all the time. So this shows it. What you can see here is it'll tell how many people are in their family tree if they have one on Ancestry and it's connected to their DNA. Okay? Sometimes you'll see a little shaky leaf that says shared ancestor. That means you and that person have the same person in both of your trees. So it tells you who it thinks you're getting the common DNA from. Remember, these are shared ancestor hints. It does not mean that's where the DNA came from, and I'll explain why in a second. Yes?
So I'm curious about this because I have two of those shaky leaves. But the problem is that some of the trees have incorrect information.
Yep, and that's the problem, isn't it?
Yeah.
That's why it's a hint.
Yeah.
Because people put bad data in their trees.
So they will not line up then.
Well, if their trees are wrong,
Right.
and you have the right tree, if you don't have the same person in both trees, you will not get a shared ancestor hint. Okay? The other thing that will cause you to not have one is if you don't have a tree, or if they don't have a tree, or if they don't have their DNA kit attached to their family tree. But you get hints about that in here, if we could see them. The next one shows that. Sometimes, I think it's down here, it says no tree. They don't have a tree, they don't have one connected. Some people have trees on Ancestry, they just haven't hooked them to their DNA. And it will say unconnected tree up here. But that means you can still go look at it. If it's a public tree, you can still go look at it and look at the people in it and see if you recognize any of the names. Okay? So this is farther down. These are second and third cousins of mine. What's nice about the new one is that they share how many Centimorgans you share with these people right under the cousin or the relationship that you expect or that they are predicting. These are predictive relationships. It was interesting. Just the other day, I'm working with this woman who's 80 years old, and she was born and adopted in Australia. So you think it's bad here in the U.S. And I found a match for her on MyHeritage, and when I clicked through to look at their shared matches, it showed a woman who it said above her name, full sister. Now, I don't know if that's managed by the gentleman that she shares the DNA with, but the DNA they share is not enough for a full sister. And so now I got to write and ask him for information without going, oh, and by the way, I don't think your sister's your full sister. I didn't say anything. And that's not unethical to do. Actually, it's probably less ethical to say, by the way, right? I mean, this guy doesn't know me from Adam. So that's where we get into some, when I talk to people who are doing family history, there are some real interesting ethical issues. Not legal, but ethical issues when it comes, I say, if you're chasing people around to the family reunion and trying to get them to swab their cheek for you, and Great Aunt Myrtle says absolutely not, there might be a reason. Great Aunt Myrtle might know something you don't know. Okay? So we have to respect that. It's difficult, but we have to respect that. There's a lot of talk in the genetic genealogy community right now about law enforcement being involved in these databases and informed consent as far as that goes with these databases, and that's the big issue. For those of you who've heard of GEDmatch, how many of you know about GEDmatch? You now have to opt in for law enforcement to be able to see your DNA in GEDmatch and use it to solve crimes. Okay. All right. So let's talk about what if it looks like you're not related. So you get this result. You all sit down at the family reunion and take your tests, spit in a tube, and you come back and you, like Pam, you find out you have a half sibling instead of a sibling. How does that happen? Everybody's like, well, duh. In modern context, there are a few different possibilities, obviously. You've got an extramarital affair, that seems to be the most common, or an affair prior to marriage, right? Two young teenagers having a baby out of wedlock kind of thing. You have a bride who's pregnant with a child before she marries the father, or marries a man, and he's not the biological father. That was the case of the friend of mine. It was interesting, they had a very well-documented tree everywhere online, except for that one marriage. And it was in like 1940 something. So you know those records are online or available. Nobody had attached a marriage record to that. It's because everybody lied and said it was a year earlier than it was. So that the firstborn child, who was this gentleman's mother, would look legitimate. Happens all the time. People change Bible records to make things work out. This has been going on for a lot of time, folks. If you think this is new, I've got news for you. We're finding it everywhere from this generation back 4 or 5 generations. Okay, nothing new under the sun. An unknown sperm or egg donor, meaning the person didn't realize they were donor conceived. Some people aren't told. The parents didn't tell them. Okay? Or you've got a different, as in the case of the friend of mine who came to my lecture, you've got a different donor than you anticipated. They thought the sperm donor was her father. It was the doctor, because he mixed his sperm in with the father's. Okay? Or you have a hidden or an unknown adoption. That's actually a lot of NPEs are finding this out that way. They test for genealogical purposes, they get all excited, and they find out they don't match anyone in their family. Not just half, they don't match anybody. And they realize that they were an adoption. Okay? Now, what about further back in your family tree? There's all of those same possibilities, well, except for the sperm donor. Well, at least not from a medical doctor. Okay, so it wasn't a medical procedure. But you might have an undocumented adoption. Think about cholera epidemics or yellow fever that goes through and wipes out most of the adults or half the adults in a small town. What happens to those orphan children? They didn't have orphanages back then. In most rural places out on the frontier, what did they do? They took them in, right? And they might have gotten taken in by extended family, or they might have been taken in by total strangers. So now that, especially if it's a baby, it's raised with those adoptive parents' surnames, so you go back 2 generations and all of a sudden grandma doesn't match anybody in that family. Or at least not in the family you thought she belonged to. Okay? Surname changes, very common. Happened when people came here, they anglicized their names, they changed them outright. That can mess with it. A son taking his stepfather's name back 4 generations and you didn't know that was his stepfather, you just assumed it was his dad, because that's what it looked like. Patronymic naming systems, where you go Carl Janssen, and then Jan Carlson, and then Knut Janssen, and yeah, good luck with that, trying to trace your DNA, because the surname doesn't follow the DNA anymore.
Yeah, my last name was changed. So,
Yeah, and that happens. And then there's just bad genealogical research data, because you grabbed the wrong John Smith in your town when there were 6 of them and you didn't sort them out properly. So you're not matching the people behind him because he's not your ancestor. Okay. All right, so what do you do about this? So my first case study, and I'll get through this, and this is actually my uncle. I mentioned that he was this. I run a Y-DNA project at Family Tree DNA, and I was so excited to get my mother's Y-DNA, my mother's father's DNA into this project. And I asked my uncle, would you be willing to test? And he's like, absolutely, this would be so cool. And we had a huge brick wall on their mother's side. So he and my aunt agree at the same time to take the test. I send them kits. This is before Ancestry was doing testing. So like I said, way back when. He takes the test. He takes forever to get it turned back in. Meanwhile, my aunt has done lickety-split. She's turned hers in. I've got her results. Everything looks good. I get his in, and I'm all excited because his Y DNA shows up. It's a totally different haplogroup. Now, we haven't talked about Y DNA in here, but I mentioned that Y DNA haplogroups mean what branch of the family tree you're on, like the big family tree going back hundreds of thousands of years. He's not even on the same big limb. My Shiver men are IN253, he was R something, or E. Totally different limb. So I knew right away something was wrong. However, the thing about Y-DNA is you don't know where the break is. That tells you nothing about where it could have happened 7 generations ago. And then I was just mad because I thought, I've been researching these people for almost 40 years and I'm not a Shiver. What the heck, right? I was just angry. But then I started to get a little nervous because I kind of know my grandma. And I decided to take my aunt's DNA, download her raw DNA, and my uncle's, and start looking for big swaths of matching A's, T's, C's, and G's, which I should have seen if they were full siblings. I was up half the night doing this, 2 days after Christmas, a couple of years ago. Actually, many years ago now. It's been about 7 years, 6-7 years, and didn't find him. He had not checked the share my matches, or view my matches, share my DNA with matches thing on the paper when he got it. And so I couldn't see his match list. So I called him the next morning, and he lives back on the East Coast, and I said, hey, I'm just curious why you didn't check that box. And he says, well, I just forgot. Go ahead, check it. This is great. I'm so excited. We might solve this big brick wall. This would be awesome. So I'm sitting there with my laptop in my lap, and I click the box. And he and my aunt, because my mom had passed away at this point, so it's just myself in there and my aunt, comes up as his half sibling. So, okay, well, if I find anything out, I'll let you know. Okay. I'm not about to spring that on at that time of the day, and I had no idea what to do. So I call my aunt, I go up to her house, I'm like, so can I come talk to you? Are you up for a visit? She just lives half an hour from me. I live in Kent, she lives in Renton. She says, sure, when do you think you'll come? I say, I can be there in 30 minutes. She's like, okay. So I go up there and we spend 3.5 hours figuring out how to tell him. And she's like, could it be a mistake? We went through all the questions that you all had when you found out you were an NPE. Could this be wrong? Did they get somebody else's kit? What the heck happened? If they'd said he wasn't related at all, I would have questioned it. But the fact that they showed he was a half sibling and his Y DNA didn't match, I knew we weren't dealing with a mistake. So we told him. It was funny. I told her, I said, you have to tell him you're his sister. You know him way better than me. So she's like, hi, how you doing? I want to tell you, Mary Kathryn has something to tell you, and hands me the book. Thanks for that. So I told him. 15 seconds after I told him, he goes, let me give you a name.
Oh.
I'm like, okay. So he did. I said, why do you say that? And he said, well, because she kept in touch with this man her whole life, and I could never figure out why. He wasn't the father. It took me 2 years to get a good Y. He had no close Y DNA matches for 2 years. And when he did, they both came in within a month of each other and they had the same surname. So then I started looking in his autosomal results for that surname. And that's when I found, well, it's funny, because now I've tested him in Ancestry. This would have been different then, or now, because there's 15 million plus people in the Ancestry database, which makes it a lot easier to identify these birth families. This woman, you'll see here, this is my aunt, his half-sister. This is myself and my sister, so we show as half-nieces. You can't see that on here. But this woman is totally unknown to us, and she's showing up as a first cousin. And so that should, that's a huge clue, right? That you've got that something's not right. So if I click on her, you go to the match page, which I've whited a whole ton out, because I swear, you try to anonymize this, and they've spread their names all over the whole page. So you have to basically anonymize the whole page. But you want to click on, down here, there's a link for shared matches. So I guess it's up here. When you do that, you get a list. What the shared matches list does for you, for those of you who aren't aware, what it does is it gives you a subset of your match list of people that match you and the person you've clicked on from your match list. Okay? So these are people you have DNA in common between the two of you. And in here, there are a ton of people. And some of them have trees and some of them don't. So we started looking. She actually had a tree. And what you couldn't see here, but her grandfather was a man of, on her mother's side, was a man of the same surname as his Y DNA. And I've long ago proven that that's also his grandfather. Thank you. So, trees are hugely helpful. When you have people that have trees, that's how you're going to go through this process of sifting and sorting and trying to find the commonalities between your DNA and these people who you've never heard of. I was lucky because I had a surname. I knew what name I was looking for because of the Y-DNA test. If you're female, you don't have that. You just have to work with your known matches and your unknown matches, okay? And I think I have a slide. Yeah, so none of his known family showed up in the shared matches list with this woman whose name starts with S. Okay, so given how much DNA they shared, 953 Centimorgans, they are likely first cousins. Because remember, it gives you a range, close family to first cousin, or first cousin to second cousin, whatever. This is how many of you have seen this chart? Blaine Bettinger's shared Centimorgan project. It's important that you get to know this intimately. What's nice about this is he's collected data that shows not just the averages for each relationship, but a range of real life people who have reported, okay, I have a first cousin, I know we're first cousins, and this is how much DNA we really share. Because it is a range. Now, the flip side of that is, these are people reporting their own DNA test results. They don't always understand what a first cousin once removed is. They don't always realize that they're really half first cousins or something. And so they've reported this in good faith, but what? People make mistakes, right? So just realize there's an error, a margin of error in here. But this is where the first cousin relationship falls, and that's where his DNA falls. And again, because I could see her tree, and I knew who his likely grandfather was, I knew that they were first cousins. And the DNA confirms that. So you start looking at her uncles, this matches uncles for a possible birth father, right? Well, guess what? She's one of 13 children, 11 of whom were boys. Yeah, think about that for a second. 11 boys, most all of whom are dead, okay? Because my uncle, when he found this out, was 64 years old, okay? And anybody who could have given him answers about it was long gone. The interesting thing was when I did get that Y-DNA match, I went to the city directory. They didn't have phone books in those days in the 40s. I went to the city directory of the small town where he was born, and there were 2 men living in that town with that surname, one of whom lived 3 houses from my grandmother. Oh, yeah. I can't prove right now which one it was, though, because both men were in town. I don't know who it was. I haven't gotten any other serendipitous testers, and I haven't had the guts to write to this woman who's the one daughter of the one man who's 3 houses away and say, oh, by the way, I think my grandma had an affair with your dad and my uncle was the result. Could you take a test? Haven't done it yet. I just keep hoping that they're going to get sucked into that kilt versus lederhosen question, and they're going to have to answer it, right? And they're going to test for me. Or the grandkids. I don't care. I'm not picky. I'm just hoping one of them will do it at some point. And then to confirm, obviously to confirm these, you have to test one of those children or grandchildren. Now I have another whole case study that's very similar that was a funny result of help. I went and taught a class similar to this. And about 2 weeks later, I got a phone call from the gal who facilitated that. And she said, hey, I've got a gal who attended your class. She wants to talk to you. Get her on. She goes, I don't know how to tell my husband he's illegitimate. I'm like, why do you think he's illegitimate? Well, she did his Y-DNA. None of the matches matched his surname. And I said, hold on. Y-DNA doesn't tell you that. Not, at least not right off. I said, have any of his siblings tested? Yes, his sister had tested. They were full siblings. I said, well, then it's probably not him that's illegitimate. But very quickly, I was able to determine that it was his father. There were no matches past his father on any of the surnames that should have been in that part of the family tree. And so that's how you can sometimes identify those farther back in your tree. And again, some of you say, well, I just found out I'm an NPE. You may find out that your birth father was an NPE, or birth father's mother was an NPE as well. And that, again, that complicates things because you're working through multiple layers of unknowns. But, and it's one thing I did not put on your handout, and I apologize for that, but I'm going to tell you right now, DNA detectives. If you have not been on that group on Facebook, Cece Moore, who you've seen, she's the kind of the face of Parabon, the one that are solving all these law enforcement cases, and she does Finding Your Roots. She's the genetic genealogist for Finding Your Roots on PBS with Skip Gates. She started this group many, many years ago, and there are a lot of what are called search angels, women and men who volunteer their time to help people like you find their birth families by using by looking at their DNA results and analyzing them. So if you are on Facebook and you have not joined DNA Detectives, I would recommend you do that. There's lots of happy stories on there and lots of not so happy stories. Reunions don't always work out. And that's one of the sad realities of what I do, is that sometimes that doesn't happen. And in the case of my husband's first cousin once removed, all the rest of the family has accepted this woman except for her birth father's family. She still has siblings. She still has a grandmother living. My husband's aunt is 91. And she has no idea she has another granddaughter out there, which just makes me sad. But I'm not in a position to be able to share that information. I can't go against the wishes of those cousins. They have a right to make that decision. And so it's a difficult thing. It's a very emotionally charged thing. Like I said, I'm not an NPE. I haven't had that happen to me myself, but I've worked with enough people that I realize how challenging this is for you. And I guess my last piece of advice is, if you don't understand the DNA piece and you need help, my email is at the top of the paper that I gave you. You're welcome to email me. Just know that I'm leaving for Europe next Wednesday for almost a month, so I'm out of time, off the grid for a while. But you're welcome to email me if you have questions, or if you'd like me to just take a cursory look at your DNA and see if I can help you. But I also have other resources and can point you in directions of other folks that can help. Okay? All right.
Can you go to certain places that, like that, can you go into the Mormon church and look for DNA? I know that they've got a huge DNA library.
They have no DNA library. The LDS Church has no DNA library.
I thought that's
They have a lot of genealogical records. They have
Yeah,
nothing. They're just as befuddled by DNA as all of you are at the moment.
That's what I meant.
Yeah, they're starting. I mean, some people, if you walk into a family history center, the people there are volunteers. They may understand DNA. They may have no idea what you're talking about. So you're really better off looking specifically for someone who knows what they're doing, who's also not just a genetic person, but a genetic genealogist who can help you then get into the records and look for those families. You had a quick question?
Well, my question is there a place we can go to hear you speak again?
Oh, actually, so my email address is at marycozy.net. If you go to marycozy.net, that's my website, I have a link that says My Lectures. And so I teach all over the area, and some of them are DNA, some of them aren't. So I teach a lot about genealogy records and research and that type of thing as well. But you're welcome to look at that, and there's some that aren't up there, so keep checking back. I get it updated. I will not be speaking at all next year, with very few exceptions, just because, especially the local stuff, because I'm going to be doing my certification portfolio. So it's going to take everything I have to get my genealogical certification. Any other questions? I'm sure there's lots of them. I will be staying till the end of the day, so if you have questions during the roundtable portion or during lunch, come snag me. I'd be happy to answer them. All right.